Good afternoon, everybody, and welcome to the 116th seminar in the Global Health Histories series. My name is Niels, and I'm an associate professor in history at Aarhus University, with a particular interest in the history of modern global health. It's a great honor for the School of Culture and Society to host this seminar. The Global Health History seminars have been organized since 2004 by the Center for Global Health History at WHO Collaborating Center at the University of York. The seminars in this series are based on the principle that understanding the history of health, especially during the last 60 years, helps the global public health community to respond to the challenges and help shape a healthier future for everyone. The aim of the seminars is to bring together academic speakers, often from the humanities and social sciences, and policy makers, often connected with the WHO, and that is what we have today, one speaker from the humanities and social sciences, and another speaker with that connection to the WHO. Academic speakers and policymakers will then debate pressing issues in global public health. And one of these pressing issues is antimicrobial resistance, or simply AMR. And today's seminar will discuss this challenge. The fact that our arsenal of antimicrobial drugs, or antibiotics, gets increasingly ineffective against bacterial infections while we are struggling to come up with new drugs. That was the very short version of the problem we are going to discuss today. Before we move on, I think I should say that this seminar is being video recorded, and that a video of the seminar will be available at the Center for Global Health History's YouTube channel in a few days. This afternoon's seminar is entitled Antimicrobial Resistance, a Global Spread, Thinking and Acting Beyond Antibiotics. And to address this, we have, as I said, two distinguished speakers. Our first speaker is Dr. Janis Helds, who first qualified as a medical doctor in Venezuela before moving to Harvard to obtain a PhD in microbiology. Janis has held positions in both academic and governmental institutions, and he has also worked in the pharmaceutical industry. From 1998 to his retirement in 2009, he worked for the WHO headquarters in Geneva, where he was particularly involved in research and development within the program of neglected tropical diseases. Since retirement, Janis has worked as a consultant, providing advice to both academia, industry, and the public sector on issues such as research and development, public health governance, and public-private partnership. Janis, the floor is yours, and I understand that you will speak for about 20 to 25 minutes.
Thank you, and it's an honor and a privilege to be here today with you. And also, I'm very humbled to have been asked to address this subject, because probably there are much more qualified people than me, and therefore I will touch subjects that usually are not touched in this thing. And the question that I'm asking myself is really the policy following the science and antimicrobial. So, as you all know, it's an old problem, but really it isn't within the recent couple, since 5 years or so, that has really gained a very high relevance in the general public. And through publications in journals, in newspapers, it's really been presented like you know, the problem that's going to lead us to doomsday. So therefore, there has been a great attention on this problem. Now, very quickly, what is the problem and how it's seen? Basically, as it was mentioned, it's a problem where the reduction of effectiveness of first-line treatments in hospital and communities is happening. Patients do not respond anymore to antimicrobials, and the infections basically become uncontrollable. The other aspect that has been emphasized is really it's a global health security risk. And I will tell you later why this is highlighted. it affects all infectious diseases. We normally talk about antibiotics for antimicrobials, but it's also case for tropical diseases, it's for HIV, for viral diseases, etc. There are some numbers that are being put forward, basically the estimated number of deaths every year due to this, 700,000. By 2015, there will be 10 million additional deaths caused by this problem, if not contained, and it has a tremendous economic cost foreseen. A little bit into the biology of this, because I think we are using and we are approaching this problem many times not really knowing clearly what are we talking about. So basically, antimicrobial resistance, first of all, it's really a natural phenomenon. Intrinsically resistant organisms, microbes, develop resistance in their environment. As you know, most antibiotics basically are derived from bacteria, from fungi in the environment. And bacteria normally in that environment develop mechanisms to protect themselves. So that is what's called intrinsically related antimicrobial resistance or intrinsically resistant microorganisms. Now, on the other hand, we have in a clinical setting, and when we really talk in a clinical setting, that's where we are talking more about acquired resistance. Basically, organisms that have lost their susceptibility to antimicrobial result as a result of probably two mechanisms. One, a mutation in their genes due to antimicrobial pressure. But then there is a second mechanism, and this one is really much less emphasized. That is the acquisition of external genetic determinants of resistance, even in the absence of pressure. Regarding this last mechanism, there are basically three things. Bacteria that contain a genetic component, genetic material that induces resistance, basically are in the environment, and somehow the bacteria takes it up, okay, and incorporates in their genome. This one is doesn't happen so often. Then the second thing is via bacteriophages, which infect bacteria and carry that. But the third mechanism is really the conjugation mechanism. What is basically, it's type of a sexual transmission from bacteria to bacteria. And there are elements called plasmids or transposomes which contains the genetic information which is basically transmitted from one bacteria to the next. But the other aspect that is not usually very highly highlighted is these things not only are transmitted vertically from within the same bacteria, but it also transmitted horizontally. It can happen that one species of bacteria basically puts this genetic material in a different species of bacteria. Another element that's very important is that genetic information, when it's transported, sometimes carry many genetic elements for different drugs. Okay? That's where the multi-resistant component comes in. So this is what I'm trying to say. It's not just about overusing antibiotics, and this is a recent publication, very interesting. Biocides or heavy metals, detergents, okay, they can induce resistance in bacteria. But then also what was determined that acquisition of resistance to these type of products also carried along with that resistance to antimicrobials. Okay, so the pressure with the antimicrobial agent to induce a resistance for certain antibiotic can emerge not necessarily by pressure to that antibiotic. Something else can also put it forward. This in a general picture, the expression of this resistance can happen at many levels. Can happen in the uptake of the antibiotic, can happen in the transport, can happen on the binding site where the antibiotic works and so on. And so basically, each antibiotic has a different mechanism of action or different target in the bacterial cell, and that target or that mechanism can be altered by that genetic information that the bacteria acquires. Now, one thing that is very important is really also to recognize what is called the spread of antibiotic resistance. in the human microbiome, basically our intestinal environment, we have all kinds of bacterial elements, among which you have always some bacterial antimicrobial resistant components. But basically, in the presence of a normal microbiome, they do not proliferate because they are in disadvantage, so to speaking. Now, basically, if you are submitted to antibiotic therapy, you are changing the microbiome environment in your gut. And then basically, the bacteria with the resistant component have an advantage and start proliferating. But those things end up in the environment. Okay, in the environment, they can now have a horizontal transmission into other bacteria, and basically enhances the pool of bacteria with antimicrobial resistance to that genetic expression. And that again is acquired by the humans and grows. So basically, a good example is if you go to some countries, a healthy individual, if you go to some countries where there's a high prevalence of antimicrobial resistance, probably when you return to your country, where you're coming, let's say to Denmark, in your intestinal environment, you will be carrying these things. Nothing will happen if you are not exposed to antibiotic treatment. If you're exposed to antibiotic, these bacteria will enhance. Now, this was very much highlighted by molecular biology studies, and basically already as early as 2000, it was recognized that there were foci of very strong multiple antibacterial resistance. And then it was also mapped that there was transit of these elements from areas to areas. And so basically, for example, there was a movement from New York to Israel, from Israel to England, from England to Denmark, etc., etc. So this is a thing that basically spreads, okay? It moves, it's not static, okay? And with the communication and travel that we have today, you know, it can easily be carried from one environment to another one. So, in the context, you have to think about two things. There are the root determinants of antimicrobial resistance, which basically are determined by the microbiology of the process, by the ecology of the microorganism, and by the epidemiology, meaning how it's acquired, about the host and the environment, and then about the transmission and propagation. Now, the attention that we have been giving in the last years are to the morbidity and mortality, which basically is the expression in the host of the inability to deal with these microorganisms. So, antimicrobial resistance is much more than just mortality and morbidity in patients. It's a whole process. Now, therefore, the technological solutions should address the medical challenge or the medical needs, but also as the determinants. Now, given the scientific and technological knowledge that we have today, we should be able to create tools that could respond to patients' need, but also impact on the antimicrobial resistant biology. So, what do we have today? Obviously, we have two objectives from this perspective. One is curing the patient, and there are many initiatives about finding new antibiotics by new methods, by improving their potency, penetration, uptake, etc. But then we have also alternative ways to curing the patients, which is basically, there are several mentions here, new peptides, non-antibiotic peptides, enzymes that kill the bacteria directly, the phage therapy, something that was developed in the Soviet Union many years ago and works for certain skin type of serious infections. Antibodies, vaccines. Obviously, vaccines should be a very important component to prevent. If you can kill the bug by vaccines, well, it never will express. Probiotics basically modify the environment in the gut or wherever it is, so the bacteria who are in disadvantage basically disappear. And then basically also the immune stimulation of the patient. But then there is also a possible approach, which is really curing the microorganism. not curing the patient, curing the microorganism, making that the bacteria who is resistant loses that genetic material or expression of that genetic material. So, why curing the bacteria is important? Because basically you could reduce the gene prevalence in humans, animals, environments. And if you reduce the prevalence of that genetic material, basically you are reducing the potential of expression. But then also curing the bacteria will leave intact the bacterial community, which is also very important. We don't want to eliminate the bacteria in general terms. It could be given as a prior treatment to patients in surgery to reduce the likelihood of resistant acquired infections, or taking international travelers to reduce the spread of antimicrobial resistance, or as a public health measure, removing these elements from bacteria in the sewage, for example. There are many ways of doing it, and there are many scientific publications, there are many proposals being done, to an extent proving, obviously in very experimental environments. It could be done with compounds, it could be done with drugs that already exist. It could be done also by using bacteria that have these genetic elements that displace genetic elements in the multi-drug resistant bacteria. It could be used phages to put these new elements into bacteria. But then also there are technologies that today are being applied in the field of cancer, molecular biology technologies that also could eliminate the genetic elements possible. So this is basically what science could offer today, and opportunities that we should be looking forward. So here I just put kind of a thing for introducing my next part. This was something that Steve Jobs said at one point, that creativity happens at the intersection of the arts and technology. And then in a magazine, UK Prospect, I found an article about arts and science equal future. Now, the question is that so, or is there something else? I mean, is just the art and science what determines the future, or is something else? So, now I'm switching a little bit, and I'm telling you about the history of antibiotic resistance at the global level from an intergovernmental organization perspective, which is WHO. WHO, together with the member states, produce resolutions for health problems. And obviously, antimicrobial resistance has been on the radar screen since a long time. The first resolution goes back to 1998, okay? And then there was another resolution in 2001, in 2005, 2007, 2009, 14, 15, and today, actually, in the executive board of the WHO for the next World Health Assembly in May, is being discussed another proposal of resolution for antimicrobial resistance. So we have 20 years of this, addressing policies and addressing things on that. But what is interesting, and again, from the perspective of history, is to look in really, as I saw it, in what context these things have been put across the years. So the first one, it's very interesting because it's very, very similar to what is being proposed today. Okay, the 5 elements, education, control, research, etc. But then in the area around 2001, 2005, the emphasis shifted, and the emphasis shifted to containment. It was really seen in the context of health security and epidemic alert. Now, there were many historical events that happened in those years that maybe could be correlated to this, but I'm not going to get into that. Then in 2007, it was emphasized from the perspective of irrational use of medicines. Okay? Bad prescription, bad education, etc., etc. Then in 1914, after all these years, okay, in one of the resolutions, the introductory thing basically said the strategy of containment, because there was proposed a strategy of containment, and it was never clear what it really was containment. okay, of antimicrobial resistance had not been widely implemented. And therefore, it was proposed what is now being done, which is the One Health approach, which is basically creating an intersectorial type of intervention, food, health, trade, etc. So this was then passed abroad at a much higher level, which was at the UN Secretary General, and in 2015 emerged the Global Action Plan of Antimicrobial Resistance. And basically these are the 5 cardinal points of that: awareness, surveillance, reduce incidence of infection, optimize the use of antimicrobial agents, and then 5th, develop an economical case for research, investment in medicine, diagnostics, vaccines, and other approaches. Now, this, again, is very similar that was said back in 1998. One of the aspects, and I think this is important to highlight, that comes out in that plan is the categorization of the antibiotics, and in these 3 elements. Since basically we are losing the very potent antimicrobials to antimicrobial resistance, so what we now are doing, we are categorizing a group of antibiotics for what's called access, first and second choice antibiotics for treating most common infections. Then watch, antibiotics with higher resistant potential that should be only prescribed for specific infections. And then reserve, antibiotics that are last resource opportunities that should be only used in severe circumstances when other options are failing. Now, this from a medical perspective and public health perspective makes a lot of sense. But on the other hand, we are asking now to produce new antibiotics exactly to attack this last group of reserve. Okay? Now, CDC, United States, the head panel, in a presentation, said something very, very remarkable. This antibiotic stewardship is good for public health, but not good for drug companies trying to turn a profit on their initial investment. So basically, this proposal is not really the best statement for a business perspective. Okay, then after that, there still was a meeting with interaction with WHO, Intellectual Property and World Trade Organization, to how to address this from the 3 perspectives. And now, today, basically, it's being analyzed a report which addresses WASH, environment. But again, the environment is seen from a very, what I would call, limited perspective. The use, the aware thing that I just mentioned, WHO basically highlights its partnership with Drugs for Neglected Disease initiatives in new antibiotics, DNDi. But in the document also, they highlight challenges. Okay? And the challenges is enhanced civil society, private sector, and stakeholder engagement. So after 20 years, we still are having trouble to deal with that in one way or another. And the emerging threats that the document highlights is invest in development of new medicines. Again, it's very difficult to get the money. So I kind of put this thing, after more than 20 years, back to the future for the affected patients. Very quickly, similar things have been produced at other levels, like the EC, for example, also produced an action plan with 12 actions. And here I just want to highlight, it's very interesting that in the interventions, they specifically talk about new antibiotics. Probably in the back of their mind, they had other technological interventions, but they emphasize antibiotics, okay? This is the last, came out a couple of weeks ago, the strategy of UK on tackling antimicrobial resistance. It's a fantastic document, very comprehensive document, very big document. And here what is interesting is UK basically proposes domestic activities, but also proposes global activities. So in a way also taking a role beyond what is in their own country interest and taking it more globally. So this somehow has to harmonize what is being discussed at WHO level. The United States also has a national strategy for doing that. And basically they have these several points, but highlighted also accelerate basic and applied research with new antibiotics or therapeutics or vaccines. The environment, the Wellcome Trust is addressed this, and the CDC and the UK services for how to deal with environment. Another very interesting document, how do you use not only social interventions, but technological interventions to deal with it. There have been created recently, within the 5 last years, many initiatives to finance research. So there is plenty of money going on into this now. And I highlighted somebody. Recently, the CARB-X, which is a group funded by BARDA, which is part of the United States Government Wellcome Trust and the Global Resistance Initiative, Bill and Melinda Gates, it has a budget of $500 million for research, and it's dedicated to basically pretty much discovery project, medicinal discovery, vaccine discovery projects. And then there are others. Now, one can ask now the question, is the science really driving the policy? Or is the science just responding to the policy? So the policy and somebody will say that I'm just exaggerating, but the policy recommendations with overwhelming emphasis on antibiotic R&D to address the curative and diagnostic medical needs. Of course, the patients are always in the first line, and we always have to save the patients. But is that really going to solve or contribute to solve the root cause of the problem? Of course, there are many other interventions, political interventions, trade interventions, etc. But from the perspective of creating tools, are we really doing very much on that? The technical solutions and tools that we are going to generate should have a global impact, therefore of application in any settings. I don't think it's appropriate to start analyzing and thinking, what are the medicines or the intervention for poor resource settings. The problem is global. The problem doesn't recognize poor settings or rich settings. It's basically present anywhere. So the interventions should be congruent. Many key countries have, like I showed in these groups, are investing a lot of money in discovery and early phases of product development. The problem is, not much is going into the later phase, into the development of these products. Okay? And basically, what's happening is these initiatives are done in a small enterprises, small groups that in theory would handle over the projects to the pharmaceutical industry or the larger development. Now, despite the fact that the pharmaceutical industry made a commitment 2 years ago to work together in this program, whatever, well, within 1918, many large pharmaceutical companies who were there basically are exiting antibiotic research. Okay, so in 2000, for 48 antibiotics in the global clinical pipeline in 2018, only 11 were to develop interventions for these drugs. And again, is WHO aware strategy impacting on this effect? I think that merits evaluation. Also, the other aspect is the issue of not an apparent, globally accepted. There are many proposals how to delink the price of the drugs that are going to be produced, okay, from the volume sold. Something recently is moving in the UK with the NICE, where that is going to be attempted to solve. So without addressing that, it's very difficult that the industry will engage, because basically developing drugs and then having the drugs kind of sitting as a contingency, okay, it's not a good business strategy. And that has somehow to be overcome either by incentive mechanisms, push mechanisms, or something like that. So pretty much to finish now, what I now did, went back to this and said, yes, art plus science is equal future, but art and science potentiated by policy. If the policy is good, you'll get there. If the policy is not congruent, you won't get there. And again, thank you for the attention, and particularly I want to thank my son, Alessandro Lazdins, who did his master's and PhD in antibiotic resistance. And again, basic science, I just make this a particular case in an excellent center, but when it came to continue his professional life, there were not so many opportunities, so he moved to something else. So again, I'm sorry that I'm putting it a very kind of bleak scenario on this, but I think we have to kind of look at the historical perspective as well as where is this all taking us from now on. So thank you very much.
Thank you very much, Janis, for this presentation on the current challenges in how to deal with AMR. And now I will give the word to our second speaker, that is Dr. Jens Seeberg. Jens is a professor in the Department of Anthropology at Aarhus University. Before joining Aarhus University, Jens worked with the WHO's Regional Office for Southeast Asia in New Delhi, and he is an expert on the social and cultural aspects of tuberculosis control in India, including the alarming, as we've just heard, the alarming development of resistance against anti-tuberculosis drugs. I mean, TB is one of the major cases of the problems created by using antibiotics against bacterial infections. Jens is head of Aarhus University's Network for Interdisciplinary Drug-Resistant Research, which brings together scholars from disciplines such as microbiology, clinical medicine, veterinary science, anthropology, health services research, and history. Very much in the spirit of the Global Health History seminars. After Jens' lecture, we will invite questions from the audience, and that discussion will be moderated by my colleague, Dr. Namrata Ganeri from the Center for Global Health Histories at the University of York. Jens, please.
Right. Thank you, Nils. And thank you, Janis, for such a wonderful overview that I think makes my job much easier. I'm going to touch on some of the same issues, but from a different perspective. My role today, I guess, is to provide a view on antimicrobial resistance from the perspective of the humanities and social sciences. And being a medical anthropologist, anthropology might dominate my talk a bit. However, the overall point I want to make is somewhat similar to the one that Janis just made. While he suggests that natural science is underutilized in global health approaches to AMR, I suggest that the same is the case for humanities and social sciences that have a substantial potential contribution to this knowledge field. This is the case, I believe, because global health tends to be informed by a rather limited selection of disciplines such as epidemiology and health economics and medical clinical trials, and there's nothing wrong with those. But none of them are really able to place global health in a wider social, political, and historical context. Hence, the Global Health History seminar series is a particular welcome as it represents an exception to this rule based on a collaboration between Center for Global Health Histories at the University of York and the World Health Organization. And I'm very pleased that Aarhus University today is also part of this endeavor. And I'd like to thank Sanjoy Bhattacharya, who couldn't be here, and Namrata Ganeri from the center, and of course also Janis Lazdins Helds for coming. And finally, I'd also like to mention that the seminar is organized with support from the Center for Health, Culture and Society at Aarhus University and by the EU Network for Interdisciplinary Drug Resistance Research. Okay, so today I want to make 3 points. One is about AMR as a biosocial product. The second point is about the separation of AMR control from the control of drug-resistant tuberculosis. And the third point is about AMR and anti-politics. So, AMR as a biosocial product. Antimicrobial resistance is best understood as a biosocial product, I argue, that is an outcome of complex processes that are both biological and social. We used to conceptualize the biological and the social as separate domains of knowledge. To say that AMR is a biological process implies a focus on microbiological mechanisms resulting in AMR. To say that AMR is a social process shifts the focus to dynamic social and societal forces that result in or hinder the acceleration of AMR development and transmission, such as overuse, underuse of antimicrobials in treatment of humans or pets or farm animals. However, to say that AMR is a biosocial product implies that these two approaches should perhaps not be separated so radically in the first place. Microorganisms are social beings as well, exchanging, as you just told us, biological material such as genetic material that protects them against antimicrobials. They communicate, for example, through quorum sensing, and they interact with the host organism, for example, the human, in ways that directly influence the ways we able to socialize. The microbiome influences not only physical health, it also impacts on the mood and interhuman sociality. So the social needs to be redefined as both an intraspecies and an interspecies dynamics of exchange. And similarly for the biological, it needs to redefine the concept of environment in ways that allow for social complexity to be accounted for. The implications of the concept of the biosocial for the ways we think are profound. The disciplinary boundaries are being pushed from inside biology in the wake of research on, for example, epigenetics, the microbiome, the human as a holobiont, and from social science, for example, through multi-species ethnography in recognition of more than human sociality and the event of the Anthropocene. 2. The separation of AMR control from the control of drug-resistant tuberculosis. AMR has emerged, as you also mentioned just before, as a focus of high-level political attention, with a UN high-level meeting in 2016 and the WHO Global Action Plan on Antimicrobial Resistance. And I guess with your past in WHO, you highlighted it was a draft. But it works as the action plan, launched in 2015. This document mentions drug-resistant TB as a particularly important threat, and indeed tuberculosis, TB, is now the single infection with the highest mortality in the world. This is so despite massive investments in TB control during the past 20 years. There are several reasons for the absence of a substantial decline in TB cases worldwide, such as concurrent population growth and widespread use of wrong treatment regimens, especially in the commercial healthcare sector. But the growing incidence of drug-resistant strains of TB, DRTB, is a particularly worrying part of the picture. DRTB constitutes around 1/3 of all AMR-related infection globally. Similarly, the WHO has launched an ambitious strategy to end TB by 2035 and has, in collaboration with a number of partners in the global TB control field, managed to create substantial international attention. This resulted in several important global summit meetings on TB, including a UN high-level meeting, even if the funding for the strategy is still unmet. However, control of drug-resistant TB is not integrated into the wider focus on AMR. In fact, there seems to be a gap between these efforts. To an outside observer, it's possible to speculate about both political and historical reasons for this situation, but I would suggest that an important reason is the long-standing verticality of TB control. A vertical health program tends to establish its own infrastructures and mechanisms of training and knowledge sharing and funding ensure a distinct modus operandi and logics, which are then added onto the existing but very different national health systems across the planet. A vertical program deals with only one disease and a limited set of diagnostic procedures and treatment options. From this perspective, the focus on AMR in its entirety would seem to be messy. AMR control has to take into consideration any use of any kind of antimicrobial for treatment and prevention of any kind of infection in any kind of organism, whether human or not. In addition, it must think of conditions of production, distribution, marketing and destruction of antimicrobials. It's mind-boggling. The AMR equivalent of the End TB strategy would be End all infections. So, from the perspective of a vertical program, such as TB, the hands-off approach seems understandable. However, it's not unproblematic. Let me illustrate by way of an example from my research in India, and in what follows I only use India as an example because I happen to know this country better than others, one could have found examples from other countries, of course. Now, in India, to buy antibiotics over the counter from outlets of medicine that may or may not be formally required is not an exception. It is common practice. Not formally registered is not an exception. It is common practice. Chemist shops function as de facto primary care practitioners, and the booming Indian pharmaceutical industry pushes drug sales through any outlet, whether or not formal medical expertise is present. Antibiotics are everywhere and consumed for a wide range of ailments, only some of which may be attributed to some kind of bacterial infection. Everyday practitioners, with or without medical qualifications, receive visits of dozens of pharmaceutical sales agents, known as medical representatives, who provide the only available kind of continued medical education cum promotion. In spite of widespread over-the-counter sale of antibiotics, prescriptions, of course, also exist. One of their important purposes is to provide information that links specific doctors with the drugs of specific pharmaceutical companies, enabling medical representatives to regularly harvest this information and reward prescribing doctors accordingly, a practice that goes a long way in explaining why doctors tend to add plenty of different drugs onto the prescription, whether or not they are medically relevant. Clearly, to address this unregulated market, one would require different measures than those needed in a vertical program, such as TB control. However, the relevance of this separation tends to crumble when we consider that more than half of all TB patients in India are treated in this marketplace, with more than 70% of TB drugs being sold in the commercial market. It's also well established that the majority of TB treatment carried out in the commercial sector are simply wrong, using ineffective combinations of drugs or treatment for insufficient periods of time, or both, thereby dramatically increasing the risk of drug resistance. Add to this that pharmaceutical companies tailor-make drug combinations to cater to this market of inappropriate treatment. Fewer drugs combined in one tablet are popular with patients because they are easier to deal with and have fewer side effects than the required combination of medicines. To make matters worse, anti-TB drugs can also be purchased over the counter without any prescription. So far, for drug-resistant TB, the global response to this has been as vertical as any other aspect of the program, pursuing a so-called public-private partnership approach through which commercial practitioners should voluntarily enroll under the program. In India, this has been largely and unsurprisingly unsuccessful. Unless the market for antibiotics is regulated through a strengthening of the public sector and based on some kind of control with the marketing strategies of the pharmaceutical sector, this problem continues. In other words, controlling drug-resistant tuberculosis should be considered within the broader framework of control with AMR. For the first time in 50 years, there are now 2 new anti-TB drugs that are being used for DRTB, but without addressing such wider issues of AMR production, their efficacy may be short-lived. 3. AMR and anti-politics. As I move to my third point, let me note that both of my previous points were about exchange, which is a core concept of anthropological theory. The first pointed to forms of exchange across microorganisms, humans and other critters of chemical substances such as antibiotics, as well as genetic material, enabling resistance to develop and spread. The second pointed to perverse exchange practices in the unregulated market, where such chemical substances are freely shared. This is not to say that there are not policies in place that are intended to regulate at least some of these practices, but they have had limited impact, which leads me to my third point, namely the role of anti-politics in global health. James Ferguson studied development discourse and its unintended consequences and suggested the term anti-politics for his critique of ongoing redefinition of failures to become success stories that allow for development of new projects within a post-colonial global financing infrastructure. This work depends on the ability to depoliticize actual flows of resources while strengthening bureaucratic structures. Policies and politics, of course, should not be confused. A policy is merely a plan to achieve an end, often accompanied with funding to enable implementation and certain regulatory measures. Politics, in contrast, is the practice of distributing resources between groups or individuals in an organization or a society. Increasing inequity in the world is the result of political interventions that shift resources from the many to the few. Policies, such as laid out in global health strategies, in contrast, often attempt to counteract health consequences of inequity. Global policy transfer may easily be stalled in the gap between policy and politics. Organizations such as pharmaceutical companies engage in policies and politics, also in the field of AMR. However, the rationale of pharmaceutical companies is not to make health, it is to make money, and I find this totally uncontroversial. I find believing otherwise naive. And I think the example that you gave earlier between what would be good from a public health perspective and what would be good from a pharmaceutical company perspective simply clash for this reason. The money-making of pharmaceutical companies may have positive or negative health consequences depending on the actual use of the products. But when it comes to AMR, most attention has been given to the use of antimicrobials, whether inappropriate use of drugs for human health purposes or for animal production. Less attention has been given to, for example, the pharmaceutical industry, waste management, and unethical marketing of antimicrobials in unregulated contexts such as the Indian as drivers of AMR. Regarding the former, waste management, consider or think of a small stream in the Indian state of Telangana called Isakavagu. This small stream is the recipient of 1,500 cubic meters of clarified wastewater daily from the Patanchera Enviro Technical Limited Company, which is a wastewater treatment plant, a facility that cleans waste from around 90 bulk drug manufacturers located in the area. In downstream water samples taken from the Isakavagu stream in 2006, 21 antibiotics were present in concentrations above the accepted normal. 11 of these had concentrations higher than 100 times above the normal. And ciprofloxacin, one of the watch drugs on this list, which is supposed to be used for second-line treatment, was found in concentrations up to 31,000 times above normal. The daily discharge load of ciprofloxacin into the small stream was equivalent to the total consumption of the drug in Sweden for 5 days. In the absence of effective regulatory mechanisms, there have been calls for the pharmaceutical industry itself to increase transparency. However, when 13 pharmaceutical companies signed an industry roadmap for progress on combating antimicrobial resistance as a follow-up to the 2016 Davos Declaration to create a, quote, sustainable and predictable market for antibiotics, end of quote, waste management was not on the agenda. A recent evaluation of 30 of the largest pharmaceutical companies found that 8 companies set discharge limits for antibiotics, but none disclose actual discharge levels. With this being the case for industry leaders, think about the vast number of small pharmaceutical companies in countries like India producing generic drugs such as antibiotics in a fiercely competitive field where the instinct to survive may overrule expensive measures to protect the environment. Final comments. I have made 3 points in this talk. One, the gap between the social and the biological should be bridged through the concept of the biosocial, and AMR should be understood as a biosocial product. The gap between AMR control and DRTB control should be bridged to the extent that drug-resistant TB is seen as part of the global AMR problem, not as a separate vertical world. And 3, the politically shaped distribution of resources influence, if not determine, the distribution of AMR globally. So politics, and not only policies, need to be addressed. Global control with AMR resembles the global handling of climate change. Most people agree there is a problem. Some have huge economic stakes invested in active denial of the facts, and political will to act globally is very slow to emerge in ways that mirror global power imbalances. To end on a slightly optimistic note, though, this societal diagnostics does not mean that we should descend into resignation. On the contrary, knowing the extent of the problem is a precondition for addressing it. To consider AMR as a biosocial product is a step in this direction. This implies systems, practices, and modes of exchange from the microscopic level of genetic material across multi-species, bacteria, humans, and other critters, and the human-made environment of the Anthropocene, in which we structure where and how much antimicrobial resistance we produce. To say that AMR is a biosocial product points us in the direction of new forms of interdisciplinary research that cannot be stabilized inside the old disciplinary frameworks. This research explores the bridges across multi-species biosociality, across humans, microbes, and other critters involved in AMR exchanges, and the life conditions they all live under, and the global and local structures of markets, policy regulation, and uneven distribution of chemical compounds with antimicrobial properties around the globe. This is clearly not any single project, but a new and ambitious research orientation where AMR development and transmission are studied as biosocial multi-species networks. Thank you.
Hello. So, I'm Namrata. I'm representing the Center for Global Health History. I'm a Commonwealth Rutherford Fellow researching the history of smallpox eradication in India. And I'm very happy to be moderating today's discussion. So I invite questions.
Yes, I'd like just to open the discussion with an observation, because this is also a history seminar, and I think that Janis said that that AMR had been on the WHO agenda for a very long time, since at least 1998. In my perspective, that's not a very long time, considering how long we have known about the mechanism of resistance. I mean, Ian Fleming wrote about resistance. I mean, a week after he discovered penicillin almost. I mean, we've known that for a long time, and what have always struck me in my own work with the history of TB control is that nobody talked about the problem of resistant TB drugs in the 1960s or in the 1970s, even the 1980s. It was only in the 1990s that there was really an awareness of this. And I wonder why is that? And I would just ask our two speakers if they have any indication why it took so long before WHO and other organizations started to treat the problem of AMR as a problem that might be a serious problem. If you get my question.
I think you mentioned something to my attention. You said serious problem. I think the issue lies in what threshold do you define for something to become serious. We've seen that in many other health interventions. Obviously, the Ebola crisis recently, when it became serious, everybody knew if you would have intervened earlier. So it's a little bit that kind of thing. In these diseases, I think there also is really a biological component. These problems really started to emerging as had a clinical manifestation of impact probably in the 70s, 80s, were noticeable. And again, since there were not so frequent multi-drug resistant things, you could cope with switching therapies and giving other antibiotics and so on. What I think was remarkable is that the policies didn't foresee where this is going all to escalate, okay? And I think, again, you said that 1998 today is not a long time in the context of the biological phenomenon. But I think it's a long time for not having had a really clear perception, where is this going to be leading us, and what should be the actions that we should have taken early on, either from the social, either from the scientific, either from the political context. And we continued going into the vertical approaches of disease by disease. I also wanted to comment, you highlighted tuberculosis, but that's not the only case. Okay, most of the tropical disease control programs are vertical programs. Most of those are based on mass drug distributions. Okay, and a lot of them are mass drug distributions based on epidemiological criteria, not diagnostic criteria. Okay, so again, we are talking antimicrobial resistance, but we continue to distribute things like albendazole, ivermectin in a mass distribution programs in school children, which is doing wonderful things until the day when these drugs are going to fail. Okay? So it's the perception, as I said originally, what is the threshold where you say, I have a problem? I don't know if that helps, but...
Yeah, no, I agree. I think in addition to that, of course, it's not only in the human health field. In the 60s, 50s and 60s and 70s, antibiotics were kind of seen as miracle drugs, and very, very quickly, huge economic interests were embedded in the expansion, the constant expansion of the use in the context of the Second World War. Antibiotics were suddenly found to be instrumental in the production of pressed pig meat, pork for soldiers, for American soldiers, and that was actually taken up by after the war by cooperation of Danish pig farmers who made the Danish equivalent called Jeka, Jakabo, is it the Jaka ham, which also was a huge success, export success, entirely based on the use of antibiotics in the pig industry. So very quickly you had very big interests that were certainly not interested in the limitation of antibiotics that was, I think at that time, the only possible response to AMR. So, and I think until very recently, within the last couple of years, we have seen also in Denmark how such interests have blocked research that would limit the use of antibiotics in Danish pig production within the ministry, which is kind of a scandal that has been totally closed down internally. But you have these huge interests that are actually involved in closing down, not talking too loud about these problems. Now it's changing because of the scale of the problem. The problem has become too big to not address, but that's a fairly recent change.
So if you acknowledge that AMR is, as you stated here, a biosocial product, what will a social medicine look like? I mean, if we can imagine something in a vial distributed to patients and so on, but from both of your presentations, it's pretty evident that there's a system challenge here as well, probably for each and every new drug you develop. So what would it be, so to speak?
That's a brilliant question. I think the best biosocial medicine will probably be of the vaccine kind of. But if we're talking about treatment options, I don't have a good answer for this. But I think that a biosocial way of thinking about it would have to consider not only the medicine as a decontextualized entity that you can then spread in various ways, but it would have to take into account, for example, what I talked about. How is this going to be marketed to doctors in different contexts? What is, does the pharmaceutical company have any accountability in terms of controlling or trying to limit development of drug resistance? When I've talked to directors of Indian pharmaceutical companies about this, they say, no, we just make it. What happens after that is not, we don't deal with that. And I think a biosocial medicine would require a different way of thinking about such issues. But I think it's a big question, and I guess we have to find out how to link these till now rather separate worlds of thinking. We have to find new ways of thinking through these problems in a different way, so that the solutions are not only dealing with what can be thought about within any single discipline, or a single discipline may be too narrow, but let's say within one kind of combined type of disciplines that, like those that would normally go into production of medicines. That there has to be a better understanding of the social life of medicines after their release, so to speak.
May I?
Yes.
I think the question you asked is really what is behind in the latest resolution in the strategy One Health, okay, where they are really trying to frame the medical interventions, with the environmental interventions, with the technical interventions, and try to put them all in context. And I think this is really the spirit of the resolution. So but the way how they approached it is by joining three basically intergovernmental agencies: WHO, FAO, and the animal OAI together into that. But I think it's a bigger than that. Okay, it's not that the FAO is going to do solutions, the WHO is going to do what they're going to do. It's basically how do you integrate these solutions in a context, and that's where the big struggle I think is going on. To generate this biosocial medicine, and then also when we think of interventions, technical interventions, okay, we very seldom think about the several compartments. He just gave a very good example. You know, when we design and produce antibiotics, we should also at the same time, as a responsible company or a responsible science or whatever, think about how to contain the problems. These guys are not throwing it out because basically they are nasty. They are just throwing it out because they are not aware of the consequences what that creates, you see. So it's each of us work from our technical compartment and don't see beyond that. And I think the One Health approach is trying to do that. The Wellcome Trust, CDC, and the UK government produced a beautiful report on proposals and evaluations of environmental actions, okay? And it addresses all these points: how to deal with contaminations, how to deal with industrial, etc., etc. But again, when you read it, it's a standalone environmental. You see, how is this strategically or implementation going to interact with the medical interventions? There is no bridging in these things. The bridging is to be expected at a much higher level, at the WHO level, at the European Community level, or something like that. But that's where I think the bridging is not happening. Okay? And so it's a process in evolution, but let's hope we don't arrive to 2050 with all the doomsday pictures and we still are trying to figure out how to integrate these things.
I think we also need to think of integration as researchers. How can we make policies possible by producing knowledge where we show that how this can be done? And I think we need to go in that direction through interdisciplinary. I think I haven't read the UK plan yet, but I surely will. But I noted that you mentioned the Medical Research Council in the UK, but actually the Economic and Social Research Council has been pioneering AMR research with large interdisciplinary research groups that were social science led to try and create new bridges across this One Health perspective. I think, if this is what has been somehow translated or inspired some of the thinking in this strategy, I think that's excellent.
Questions and comments?
I actually have one question, which is a much more direct question, but I'm wondering, based on your presentations, wouldn't it be possible to make a case that, production and distribution of antimicrobial drugs should be de-linked from the private sector? Because as both of you are emphasizing, it is actually it's bad business, because you want drugs that are expensive to develop, and you should sell as little as possible. So why not simply say that this is not for the private sector at all? It should be restricted to governmental agencies. In theory, that
something is happening, and I think last week or 10 days ago, the UK government, and again, it seems like UK is much more in the forefront. They released in the public an initiative, exactly what you say. Okay, and I mentioned in the slide, they link the cost of the products from the volumes of use. Okay, and that's going to be done through the NICE program. NICE is basically the component in the government which figures out which therapeutics to put in a context of the public health with a cost-impact positive ratio. So it has not been disclosed how they're going to do this, but for these special antibiotics, basically a lot of people are seeing that this could be really the true incentive to engage into that, even for the private sector. So we are all waiting what is going to be really the government plan for doing that. I just wanted to add, you said about scientists. I think I've been a scientist, and you saw from my presentation, we are not good communicators.
We didn't see that.
Fundamentally. And I had seen that in many events, at the high level. Communicators in the sense of communicators with policymakers. Okay, we tend to kind of get lost in, and I unfortunately did fall into that. Get lost into the detail. And again, it's very remarkable when you go to these high-level meetings. It's very seldom that you have the scientists who are generating these things participating in these discussions, or that the governments take along the best brains that generate the science to these discussions. At the World Health Assembly, it's always flabbergasted me. There are the governments, and then there are the other elements who participate, civil society associations. Well, there is the medical associations, pharmaceutical production association, whatever. I have never really seen any research association sitting there. Okay? So maybe there is something into that, okay? That also is a point to think a little bit out from the anthropological perspective.
I think that if you're a good scientist, and that is whether, in whichever field and from whichever corner, on a scientific basis, you are not good at making compromises, because your field is to do the opposite. That is to know what is the best, right, or what is right. And so that might be one reason we are too difficult to have at the table, because we kind of, have too much sand to throw into the cogwheels. But I'd like to get back to your question and just remind us that the Danish state just sold the State Serum Institute, which has had a very long and glorious role to play in vaccine development. And, in my view, that's a disastrous decision. It's the opposite of what we ought to do. We ought to, as a state, the state should have developed a better mechanism to have this kind of institution, rather than just to say we don't know how to have something that has this kind of company-like status. So one could have developed ways to have that kind of institution and expand that, for example, in the field of antimicrobials or antibiotics. And we just shelled out 14 billion kroner to some crook in the UK who kind of emptied the treasury. We could have spent that, that would be enough to look at least one drug. So I think we could if we wanted to, but it seems we don't want to.
If I may go back to that very interesting point about why the, let's call it, two areas are not communicating, why you don't see scientists at policy-making conferences and so on. I made the same observation and thought about it also, and we've had an interest in anti-inflammatory therapies, where it seems that you can discuss the application of these therapies in the public without ever mentioning what exactly they're doing. So I think this problem persists. I think it's a training issue. One would also like to bring to mind this old essay by Charles Snow, Two Cultures, where he made the observation among his learned friends that somewhere in the cultural field and somewhere in the scientific field, but that not a major exchange. And I recall from my own teaching that at least the formal curriculum in a scientific training would not involve any thought of science as part of society. One could ask in the cultural science how often you do thermodynamics. That was Charles Snow's also observation that was maybe a little bit lacking. So I think actually one could argue that in this pressured world in teaching people that we ought to install more courses talking about this phenomenon, that your medicine is not simply doing something in a biochemical sense, but also will have a sort of life of its own in the pharmacy shelves.
Yeah, I mean, the example I tried to use to highlight this point was, if you go talk to the biologists, molecular biologists, antibiotic resistance, they had emphasized times and times about the transmissible character of the problem. Okay, but that has not really been picked up very much in the policies. The policies are to treat the consequences when you have the disease. But from an epidemiological perspective, you could also think about a strategy of dealing as a transmissible disease. Just as you do prevention and as you do control of transmission, you see. And something like that was insinuated in the early phases when containment was the key word. But then it dropped, okay? But the evidence, the scientific evidence, the molecular basis of it, the spread globally of the problem has been continuing growing. And there are many publications that go to an extreme detail. But that, again, it's presented in a way that is too complicated for people who are not expert in the field to translate into actions.
I think there's also another, I think that's true, but I think there's also another dynamics at play, which is when you are in these kinds of meetings where policy has to be the outcome of the meeting, it means that you need to produce solutions. So somehow you need to have the solution in order to select the problem that you think you can solve. So you cannot deal with problems you cannot solve in that world. And that actually blocks out a lot of AMR problems, because if you can't show a way to address them, then they have to be ignored basically. You can't have a document saying we don't know what to do. That's a no-go. Especially if you want to have funding for your strategy, right?
Please.
I was wondering, do you think we have lost some knowledge in the way we teach people also? I work with infection prevention, and I often encounter healthcare professionals who actually still seem to think that infections are a small problem that we can easily solve. And I'm just thinking, when I started out, I work as a nurse, when I started out 30 years ago, I had older colleagues who had treated patients with polio. They had a very different approach. And I'm thinking, are we teaching people the right way? Have we lost something in the way we educate people? Because we've had a number of years where we thought well, antibiotics can solve everything and infections are a problem of the past.
Absolutely. You know, I won't tell you when, but when I studied medicine, okay, the amount of microbiology that was in our curriculum was no more than one semester, because it was not worth studying. All what you needed to do is give antibiotics, okay? And that persisted pretty much till today, okay? And I think exactly the problem that is emerging, okay, it's asking to revisit the curriculum. But that makes me, again, reminds me a very important point. In these high-level discussions, in this multi-stakeholder partnership, education is mentioned very few times. You know, it says you have to educate the physicians, you have to educate the service providers, but are we really taking it to the whole extreme, to our medical schools, to our nursing schools, to our public health schools? You see, are universities changing their curricular approach to deal with a problem like this? And that, I don't think it's quite there yet.
I can actually elaborate a little bit on that, because I know it's more or less been taken out of the nursing education. There is basically no teaching about microbiology and hardly any on infection prevention.
And for years, how did you learn how to intervene and do therapies in infectious disease? Through medical visitors from the pharmaceutical companies who came to you and told you, this antibiotic is new for doing this.
And the best.
Well, but again, you know, that was the reality because nobody else was teaching that.
Yeah.
Okay? I think it's time that we really revisit that.
Yes, we have a response. A question of
as a medical student today, I believe we have a lot of education in infectious diseases because we have a whole semester in microbiology, and then we have it in the pathology courses, and it's a semester again in the master's degree. So I believe that the educators are making a point of showing us that it's a problem.
Do you know if that has changed in recent years, or?
We have a new study report, but I don't know.
Well, I mean,
how recent it is.
yeah, I think, I mean, certainly the microbiology part is very important there still. You could argue that maybe the reform that we are undergoing would probably try to bring basic science and clinic closer together. So that is one of the things in a way that we, us representing the basic science, selects cases which would be helping the clinical understanding. So that's the way this part is working. And I have to say that, not to take any pride in our institution compared to so many others, but nevertheless, the microbiology part has always been very prominent in Aarhus, thanks to my colleagues in the field. And I think also the resistance problem has been dealt with explicitly in I think the seminars.
Yeah, there are several lectures on that.
But if you can still argue though that I think still it has come as a surprise to us how big this problem has become.
And consider that Denmark is one of the best countries in dealing with it.
Yeah.
Yes, please.
And I would just like to comment on that because, I mean, microbiology is one thing, but infection prevention is equally important, and that is not emphasized to the same degree. At least it isn't in the nursing education.
I think we are trying to make a point about it somehow, but
I think in a clinical setting, it's something that we do in the master's degree, and I haven't reached that yet, but I think we don't emphasize it enough. We could do more. We could do like lectures about what to do specifically and teach it more hands-on.
No, but I
And
think
not just theory, because we get the theory in our antimicrobiology courses, but we don't really get the hands-on experience with how to do it.
I think it's interesting to have this dialogue between nursing and medicine, because, you know, it seems that it's percolating faster into the medicine, study of medicine compared to nursing, where something like infection prevention should be a huge thing, right? So I think that's really interesting and somewhat disturbing.
Well, I think it's because it's left up to the individual school, so they can sort of make their curriculum themselves, and there is no, I know in the nursing education, there are no exams in this anymore, and that does something.
Yeah, that's interesting. Disturbing, but interesting.
Have we any final comments? Or can we draw this to a close?
All right.
Yes, thank you so much. So from talking about, I mean, this discussion has opened up ideas of AMR as a biosocial product, to what biosocial medicine could be, to discussions about dialogue between researchers across different streams, and finally we come a whole circle with education and curriculum. So I'm quite sure it's been a very productive exchange of ideas and a very useful discussion, and lots for us to think about even later. You can email our respondents here and ask them questions if you would like to, if thoughts come to you. Thank you so much. Please join us for coffee.
Yes.